So let's have this problem. So calculate the force between the two charges. So we have the positive charge 25 times 10 to the power negative 6 coulombs, and the negative charge 60 times 10 to the power negative 6 coulombs. Then the distance between the two charges is 2.5 centimeters. So to solve for the force using the Coulomb's law, and this is the formula for the Coulomb's law, so we have K and K. So this is the standard value for K. That's 9 times 10 to the power 9 Newton meter squared over the Coulomb squared. Then Q sub 1 and Q sub 2 are the charges, and D is the distance between the two charges. So from this given, Q sub 1, the first charge, that's 25 times 10 to the power negative 6, and Q sub 2, the second charge, 60 times 10 to the power negative 6. Then D, the distance, that's 2.5 centimeters. But we need to convert these centimeters to meter, since 1 meter is equal to 100 centimeters. So cancel. So we have now the distance in meter, 2.5 divided by 100. So this is 0.025 meter. Then this time to solve for the force using the Coulomb's formula. So we have K, and K is 9 times 10 to the power positive 9, then times Q sub 1, the first charge, that's 25 times 10 to the power negative 6, then times Q sub 2, that's 60 times 10 to the power negative 6, then over the distance squared. So the distance in meter, that's 0.025 meter, then to the power 2. Then to simplify, to solve for the force, so bring down this K, then multiply this 25 and 60. So 25 times 60. So we have 25 times 60 equals, that's 1,500. So this is 1,500 then times 10. Then for the exponent, since we multiply, so these two exponents you add, so that's negative 6 plus negative 6. So the exponent becomes negative 12. So this is times 10 to the power negative 12. Then columns times columns, that's column squared. Then for this denominator, so we can distribute this exponent. So this becomes 0.025 squared, then meter squared. Then we can cancel this meter squared and also this column squared. So the remaining unit is in Newton. So to solve now for the force, so multiply this 9 and this 1,500, then divide by 0.025 squared. So we have 9 times this 1,500 equals, then divide by 0.025 squared equals, so this is 21,600,000. So 21,600,000, then times 10 for the exponent. So again, since we multiply, so we need to add these two exponents. So we have positive 9 plus negative 12. So the exponent is negative 3. So this is times 10 to the power negative 3 Newton. Then to rewrite this in a standard scientific notation, so we need to move to the left. So we have 1, 2, 3, 4, 5, 6, 7. So therefore, plus 7 for the exponents. So we have the force equals 2.16. Then for the exponent, negative 3 plus 7, that's positive 4. So times 10 to the power positive 4 Newton.